Всем hi. So, welcome to my talk. It's a nice talk. Let's get a little bit introduced to each other. My name is Sergey, as you can see. I'm a game developer. I work with Lua engines, Corona, Defold. I do consulting, plugins, Lua stuff, lots of stuff. And you guys, are you game developers? Anyone from here? 1, 2, 3, 4, 5. Well, yeah, so few of you. So maybe do you use Lua in your games? Yeah, nice. Okay, so for the rest of you, this would be something new, I hope, and something really interesting. So what is Defold? Defold is a game engine. It's lightweight. It can handle 2D, 3D graphics. It has Lua scripting. We all love Lua. And it has a website. It's called defold.com. And it's not Defold like in 1998 Defold of Russia. It's different Defold, but it's spelled differently. So Defold, it's like it's folded something and then defolded, something like that. Stupid name, but anyway. It's multi-platform. It can run iOS, Android, macOS, Linux, Windows, HTML5. Nice. And Defold is also this program. Yeah, you can see it. I hope you can see it. So what it does, if I hit run, it will output a black screen. A black screen is a start of a new project, of a new life, of anything. So to get anything on the screen in 3D world, you need shaders. Shaders is what makes stuff possible. Anything that you see on the screen in games is a result of work of some shader. And shaders are really fun to code with. So let's have some image. In Defold, we go to the main collection file, which is like a level, is like a stage, and we add a game object. Let's call it image. And in the image, we will add a model component. Model is like a 3D model or a flat model, which is suitable for rendering sprites and textures. Assign a material to it. For example, diffuse material, very simple one, and assign an image to it. Now, if we hit run and Defold builds the game for us, we can still see the black screen, because most often when you do stuff and you don't see where it ends up because it's not sometimes so visual process. And in this case, our image is too small because the model has coordinates from -1 to 1, and our screen has a larger pixel count of the window. Now I increased the scale of image model, and if we run it this time, we will get a dog on the screen. This is my dog. His name is Steven. Say hello to Steven.
Hello, Steven.
Steven says hello to you too. And what can we do with him? So I assigned a material to the dog. You know, dogs are made of fur, but in 3D they're made of code, just pure cold code. And so this diffuse material is just a collection of two files, Vertex program and Fragment program, which are two types of shaders that we can deal with. So what is a shader exactly? A shader, let me open a picture for you, is a crucial part of a rendering pipeline. You know, each model, everything on the screen consists of vertices. It's like points in three-dimensional space right here. And they have to be transformed to the screen coordinates and maybe animated somehow. This is all done by Vertex Shader. This is first important shader program. Out of these vertices then constructed some geometry that is suitable for graphics driver, for the GPU, and then it gets rasterized, transformed to actual pixels from geometry to pixels, and then each pixel gets shaded, gets colored with a certain mathematical function or a program, and it's called a fragment shader, fragment program. And like this, it gets output on the screen. So geometry gets translated to screen coordinates and then gets rasterized into pixels using two programs, Vertex Shader and Fragment Shader. Let's have a look at the Fragment Shader. For example, this is the most simple one. This Fragment Shader just takes a texture, takes coordinates within the texture, and returns the color of the texture to the screen. Very simple one. Let's do something interesting with this. Let's change the material to another one, which is just a copy, basically, and open this Fragment Shader. And for example, let's forget about texture for now, and what we can do here. First, we can output a color. For example, a color is a 4-component vector. For example, if you want a white color, that would be a 1, 1, 1, 1, 1. And if we run it, come on, build faster. We get white rectangle on the screen. Pretty exciting. Not so much. Let's do something more interesting. For example, these coordinates for within the texture. They are also of vector of 4 components. And we can actually output as a color. So if you run it like this, we will get on the screen nothing. Oh, sorry. It's a vector of 2 components, and we can add 2 more. And we will get a color representation of the texture coordinates on our image. So this would be a red one is 0, 1, green one is 1, 0. Actually, the other way around, but who cares? And the yellow one is 1, 1. So this black one is the top, is the bottom left corner of the screen, and 1, 1 is a top right corner of the texture. So this is how it's done. And let's get back to our color. For example, vector for color, let's copy it and output like so. And we can now modify the color, and we can, for example, assign red component to 0, and we will get a dog that is without red component. So this sort of stuff, it's fun to do. And with shaders, you can do a lot of interesting and visually fun stuff. So that's fun. But how can we do this with Lua? We can't. But we can, for instance, delete everything here and specify the color from Lua. We need to define the color as a uniform variable. Uniform means that its value can be assigned from outside the shader. And let's create a script file for our image. Script file is a special sort of Lua file within the Defold engine, which deals with different game object stuff. And then we can add this file to our stage. And now we can control our variable from within this script. So we can call model set constant. So model set constant is a special API of Defold, which allows us to change stuff in the shader. URL of the model is just hash model. Our constant that we just created was named color. And the same way, we assign a vector of 4 components. For example, if we want red color, that would be 1, 1, 0, 0, 1. The first component is for alpha. We want alpha to be 1 for it to be visible on the screen. Now, when we run it, Defold sets the color to propagate the color value to the shader, and shader knows it's red color. Nice. But that's not all. Defold also has another set of API which called GoSet. Go stands for game object, set stands for setting various stuff. And it can actually do the same thing. It's just a broader function. And it can work with other stuff. So if I run it, it will be the same output as before. But now comes interesting part. Another API in Defold, it's called GoAnimate. And what it does, it can animate between 2 values some property of a game object. In our case, that's the color constant. Playback would be how we would like to make the transformation. The simplest one would be playback once forward, just from one value to another. But more interesting one would be loop ping pong, which would alternate between 2 values back and forth. So next, we will set up the values that we want to our image to take. For example, that would be green. Easing. Easing is just another function that takes control of how the value is transformed along the way. And for now, it would be just linear, and duration would be 1. Is it big enough? I can. Yes, thank you. So if we run it now, it's animating, it's flashing. Who likes flashing colors? I do like flashing colors. That's interesting, right? But that's not all. For instance, Defold also lets us pick up values not from the code, but from the editor. How it's done is that it has another function that's called GoProperty. We can assign the name of the property. It would be the property of the script file value, and assign some default value for the property. In our case, that would be black color. And when we are setting the color, we would do it like so, from within self. Self is an instance of the script component in Defold. And now you might notice it right here. And when we go to our image script in the scene of Defold, we now have this special field with the color name. And that is our color. We can, for example, make it like so, 101, which would be what color? Who can guess? 010. No, another way around. Why I'm messing up numbers? It's pink. So it's from pink to green. Nice. So yeah, it's interesting way Defold deals with Lua and how we can propagate from, you would say, level editor values back to the shader, down to GPU. I like how it's done in Defold. It's interesting. It's not visible in here, in main collection, because it has to run Lua code for it to be visible, and in the editor it doesn't do it. It just runs Fragment Shader, and Fragment Shader has the black value for the color, and so we can't see anything here in the editor, but that's not too bad, right? Now let's talk about Vertex Shader. Let's return it back to normal. Texture 2D. Take a pixel value from our texture. Make sure it works. Steven is back on screen. He missed you. Did you miss Steven? I missed Steven. He's at home, and I'm here. So let's open up the Vertex Shader for the model. What it does, it takes the position of vertices of the model and transforms them depending on the matrices supplied by the engine and transforms them to screen coordinates. For instance, if we take the model that I was showing you, it's this one. It's just plain 2D mesh, and if we go to edit mode, you can see individual vertices. So these vertices gets modified by the Vertex shader. So, and Fragment Shader takes, for instance, 3 vertices. They form a triangle, and Fragment Shader shades everything that is between this area with some specific color. So that's how games work in modern game engines. Back to default. So let's copy our position to a temporary variable and assign it here. Now we can modify it. For example, we can increase the Y value of our image by 0.5, and if we run it, you can see that all vertices of our image were moved up a little bit. So this is how it works. Shaders transform vertices and they get moved on the screen. That's nice, right? Let's make it a little bit more interesting. Let's, for instance, have it dependent on time variable. Time, I also supplied by vector 4, but we only need one value. So I just use the X value to hold it. And if I run it, now dog is flying in the black void of the screen. He's sleeping. He likes to fly around in space. And where this value comes from? So this is a uniform as well. But if we go to render script, this is a script in Lua that controls all the rendering pipeline in Defold. So what it takes? In the init function, we define our predicate for the model, which basically takes all the model with all materials with a specific tag. So if we go to the model material, you can see model tag right here. So this is how it knows that we want to render a texture. And there's a constant buffer. In this constant buffer, I can put various parameters, and they get sent to all the shaders that have them and that want them. So this way you don't have to specify time variable for every model in your game. You just specify it here once, and then it propagates to every instance if you have many of them. And it's done with the draw command of the default, render draw. It takes the predicate that we want to render and a constant buffer that with a set of variables that you want to. So shaders can have them. Let's go back to our example. Let's, for instance, decrease the amplitude, increase the frequency, and maybe make it dependent on the x value of the vertex. And if we run it, the formula like so, we now have this strange movement, which is not well suited for a dog, would you? And let's maybe change the image a little bit, make it smaller, and replace the actual image, replace the model with a bit more detailed model, which has more vertices. If we go in Blender, I want to show it to you, and import this new model that I'm using. It's quad 4x4. And if we go to edit mode, you can see it has more geometry, more vertices. So if we have more vertices, we can do more stuff with the geometry in shader or in the model, anywhere. So, and if we change the image, for example, to this, and run it, we can have a waving flag of Brazil with a simple formula in the Vertex Shader. This is nice, right? I like it. So yeah, this is how Vertex Shader works and how we can control them from within Lua using the Defold engine. And as a bonus, I want to talk to you about some limitations. So you see this language is called GLSL that Defold uses to compile shaders. There are different shader languages, but this one is one of the most used. And this particular version of this language can run on many devices because Defold runs on many platforms. It has to support least powerful devices, and these are mobile devices. So you basically write shaders for mobile devices, and they get compiled for desktops as well. There are some limitations. And there are limitations of Defold on top of that. For instance, you can only specify vector 4 parameters for the shaders. In general, shaders can accept many various forms of parameters, arrays, matrices, other stuff. But Defold supports only vectors of 4 components. And it can only support 16 such parameters at the same time for one shader. So what I've done is that I've come up with a way to use all 16 parameters. I'm changing the scene from what we've been using to another one. This is the same dog, but with dots. And each dot, each circle represents a vertex position within the model. And if we click it, we can transform the model. You see how big the dog head is now. And it can move legs when it sleeps. Do you have dogs? Do you know how they move legs when they're sleeping? This is how they do. And how it's done. It's not pretty. So if you know OpenGL and shader programming, please forgive me. But I'm going to the Vertex shader, and there are 16 such variables for each vertex inside the model. And in the vertex, I have a wall of if-else statements, and I just compare a position of each vertex inside the model. I identify by this means the vertex and change its position to the supplied value. In normal GLSL code, you could write GL vertex ID, and that will essentially give you ID of the vertex, but it doesn't work in Defold, and switch statements don't work on mobile devices. So a lot of limitations. And in the script that controls this everything, I want to show you, so there's an init function that initializes the scene. And when I do it, I create a circle for each vertex. And I identify this circle with vertex parameter of the model of the shader, and on the mouse click event, I look what circle was clicked by comparing the position of the screen and position of the vertex, and I move the vertex and update its value in the vertex shader. So this is very basic code, not much Lua lines, but it works and it produces this nice result. So that is about what I wanted to share with you guys. If you want to know more about Defold, about Vertex programming, you can ask me, or you can go to Defold website, or you can watch other talks that I have on Defold. I have many of them. They're interesting as well, I promise you. Well, not most of them, but some of them are interesting. And yeah, this is it. Thank you guys for listening. Do you have any questions? So who can control the microphone? Isn't on the chair?
Hello. The question is, in the first example, could I put a value into uniform using callback? I mean, at each frame, that callback should be evaluated.
Yeah, using what exactly?
Callback.
Callback?
Yeah.
Like a function in Lua?
Yeah, yeah.
Well, that's a trivial task. I'm not sure what the question is, maybe, but you can set up a function and call this line from anywhere in Lua, and it will work.
That's different about modeling the engine. I mean, with callbacks, I can design stuff that trigger up later. If I have just a pre-render function when I have to execute all the callbacks, it's different modeling of a
Yeah, it will
engine.
work because set constant function, it accepts the URL to the model that you want to modify, and URLs are accessible from anywhere and from within any callbacks in Defold engine. So it should work, if I understand you correctly.
I get it. I get it that is done through models, but can the models be triggered by events? Then the question is.
Not sure what you're asking. Sorry.
I mean, I don't want to put it all into pre-render callback, pre-frame. Just callback, big lot of things executed before a frame. I want it to be tiny little callbacks. I know I want this factor animated. It just should return some kind of sinus function or something like that.
Well, you can define some sort of structure in Defold for that, but generally Defold gives you this update function, which you can call each frame and update all the values in a callback each frame.
Is it attached to something or is it global? I don't get it.
It's attached to the script component. So a script is a Lua file that is attached to some game object.
So it's also global level update, right?
No, it's not global. So it's local to the script.
It's game object level.
Oh.
So
Many game objects in a scene, and every single one has its own
I can
update
create
function.
a new object to each model, right?
yes, you can.
Got it. Thank you.
You may see this function here, which looks like a global, but it isn't in Defold engine. So it gets, so other scripts don't see other functions from different scripts. So they are kind of isolated.
Default replaces the global environment.
Thank you.
Yes.
To do this.
Got it.
Another question, please? Oh, lots of questions.
As we can see, there is a global update function.
Yeah, as we talked right now, it's not global.
It is global in lexical sense.
Yes.
In lexical.
I don't like it about default, about this syntax, and I don't use it. I use some wrapper around it, so it doesn't look like this scary. But
so
yes,
it's completely wrong that there is a one Lua state for every script.
Lua states are different stuff. So here's the default runs in one Lua state most of the time, and from the render script I can import. I can require a Lua module, and from another script I can define require the same module, and they can communicate with each other through that module. But all these functions, they don't overlap.
We don't see that stuff in this model. It's I think it's better look that there is a table, local table, with methods, and return that table.
Right, but if we're talking about scripts in default, there's another about how they get processed. So right now here you write the code with global functions, and when the default engine processes this file, like in the end, it takes all these function references from the global scape, deletes them, and puts them into user data meta table for the script instance. So it's tricky, but it works for them.
Do you think that there is some performance hit?
No, because it's just only initialization. There's a performance hit for user data self value, because self here is a user data, and when you index this value, it calls a meta table, and there's some performance hit, but it's also not so big, and you can replace it.
Okay, we can say that script starting once during the scan render, and no matter how long it starts.
Mm-hmm.
Okay. Thank
you. There's one script instance per one game object that we create in the game.
Thank you.
Very interesting demo, thank you. Could you tell us a little bit more about that language with extension FP and VP? It looks like C, but it doesn't, I guess. So
yeah, this language is called GLSL, GL as in OpenGL, graphics library, SL shading language. It made look like with a C syntax, but it's not C. You can't make a lot of C constructions in here, but it's very similar, and some of it can be ported to it. And if you go online and see all the functions that GLSL give you, there would be some interesting ones to work on vectors, on matrices, on colors, on so it's just a specific language for graphics processors, and this language support is implemented in each video graphics card.
Mm-hmm. Is it something common for game development domain? Yeah?
Yes, it's common.
And even for graphics at all? Yeah?
Mm-hmm.
Okay, thank you.
Now we have many competing graphics APIs like Vulkan, like Metal, and there's currently a big war going on between NVIDIA and Apple. So maybe we will not see GLSL in recent future. Who knows? It's interesting to watch how it goes.
More questions, please?
And to remind you, we have a workshop where I will, using Defold, make a platformer game, a simple platformer game. So if you would like to watch me how I do it, join me at the workshop.
In a half of an hour, actually in 16:15, 4:15, in the Kinozal, Sergey will continue or start anew.
Yeah, I will start from scratch and I will show how a character can move on the screen and jump and not fall into the infinity standing on the platforms.
Okay, any further questions, guys? No more questions? Then
Can you ask you a question?
Yeah, you have to raise the hand and give you something, Mike.
Sergey, simple question. This GLSL file, can it be generated with Lua and translated in runtime?
Well, if you write such thing, it might, but there's not much point in doing so because it has to be very efficient and with specific function calls. So not much point in doing so.
But if you do it offline, before the game starts,
well,
the build time.
The beauty of GLSL, it's syntax, which is missing in Lua. So it's not. So Lua is not the right tool for the task here.
As Roberto said in the first
right.
talk.
I think Lua is a good thing to generate it and to exclude this boilerplate, to write it in a more compact way, if we could do it. Metaprogramming.
Well, then you will want to work with tables in Lua, and they cannot be easily transformed into GLSL, into the C stuff.